Ma'am, recording on নাই।
Ma'am, assalamu alaikum, ma'am. I'm roll 47. Ma'am, assalamu alaikum, ma'am. I'm roll 47.
Yes.
Ma'am, আমি ফিজিক্সের সবগুলো ক্লাস করেছি, একটা ক্লাসও মিস দেই নাই। কিন্তু আমি এমকেএম এ ঢুকে দেখেছি যে আমার এপ্রিল মাসের হচ্ছে এই বুধবারে 2টা ক্লাস অ্যাবসেন্ট দেওয়া।
তাহলে অথবা ওটা ইয়ে ছিল না, তোমার চ্যাট বক্সে রোল নাম্বার ছিল না। বুঝতে পেরেছো? আমরা যখন চ্যাট বক্সে রোল নাম্বার দেখি তারপরে তোমার অ্যাটেন্ডেন্স দেখা তো হয়তো কোনো কারণে মিক্স হচ্ছে।
মানে এটা কি ফিক্স করার কোনো সুযোগ নাই?
তুমি আমি তো অলরেডি একজনকে বললাম যে আমাকে ইয়ে করতে, যদি কারো অ্যাটেন্ডেন্স তোমরা কি এখন দেখতে পাও অ্যাটেন্ডেন্স?
কালকে ম্যাম দেখতে পেয়েছি। তো
তুমি আমাকে ইয়ে করে রাখো কোন দিন কোনটা রোল নাম্বার দেখে আপনি ডক্টর
আমি আপনাকে হোয়াটসঅ্যাপে মেসেজ করে রেখেছি।
ওকে, ঠিক আছে। So now we're going to start another chapter, that is interference of light. Interference of light. So, acha, everyone is attached with the Google Classroom. We have a Google Classroom given, and everyone is a member of that Google Classroom. You know the code number of that Google Classroom? Are you listening or not?
Yes, ma'am.
You know the Google Classroom code?
Yes, ma'am.
Okay, so tomorrow you have to deposit your script on the Google Classroom. Okay, that's why I'm asking. Okay. So, any idea about interference? Like interference, what is interference? Any idea about it?
Recording
What
in
is
progress.
interference? You know it. I know it's in HSC. You read this thing, interference of light. What is the meaning of it? Interference. What is the meaning of it?
Batha.
No. Yes. Then.
Meeting of two waves.
Okay. Basically, interference of light is that is it is the modification. First, step by step, you have to understand. It is the modification in the distribution of the energy. Modification is the distribution of energy. Why? Why this modification? Because of the superposition of two waves. Is that clear? Because of the superposition of two waves. Okay, like okay. So this is one wave. Okay, one wave and another wave. This is another wave. So when this wave is superimposed here, okay, like if it is in the same path as like this, the crest of one wave falls on the crest of the another one, trough of one other wave falls on the trough of the other one, then they create the constructive, that is, we get the bright point. Okay, but when this wave falls in opposite direction, like this, see, in the opposite direction, then what will happen? In the opposite direction, then what will happen here?
Distracting.
Distracting, yes. That is, the crest of one wave falls on the trough of the another one. So they minimize each other. So the resultant we get, that is the dark point. Okay, we get the dark point. So on the screen, we get the interference pattern like this. That is, the central one is bright. After that, alternatively, bright, dark, will give. That is, center one is bright, then again bright, again dark, like this. Okay. This is bright, and this one is dark. Okay, this one is a dark portion, and this is bright one. And this is the dark portion. Okay, so see, so the bright one we are getting, this one we are getting, the amplitude is more. Okay, the resultant amplitude is like this. Okay, it is increased. Okay, so this is for one wave, wave number 1, and this is wave number 2, and then this, the third one, that is the resultant. Okay, the third one is due to the resultant. Okay, 1, 2, and it's creating the third one. Resultant, we are getting the bright one. It is the bright portion. Okay, it's bright. Okay. And this one is first one, wave number 1, and this is wave number 2. And resultant we are getting, that is resultant, and it is dark. Okay, so it is the dark one we get. So if we go on the screen, if we see, you see the pattern is like this. The pattern is like this. So one is bright, another one is bright. Alternatively, it's gray. And this is known as the constructive interference. That is known as the constructive. This is constructive, and this one is the destructive. One is constructive, another one is the destructive. Okay, now come to the definition. So, have you seen there is a change in the energy? Is there any modification in the energy? Yes or no? Is there any change or modification in the energy? Wave energy. Is there any modification in the wave energy? Yes or no?
Yes, sir.
Yes.
অ্যামপ্লিটিউড বাড়ে এইজন্য এনার্জিতে ডিফারেন্স হবে।
Yeah. Yes. So now come to the definition of the interference. That is modification in the distribution. That is the distribution of the energy. So modification in the distribution of the energy due to superposition of two waves. That is the superposition. That is the superposition of two waves is known as the interference of light. There are basically two types of interference. One is the constructive, another one is the destructive. So when we get the constructive interference, we can tell what is when we get the constructive one. What is the criteria for getting the constructive?
And the crest and the cross align.
Okay. And what is the condition for destructive? What is the criteria? You may get question like this. When we get constructive or destructive interference? Okay. And what is the condition or criteria for destructive interference?
When the
Same phase hole.
Just simply opposite. One crest of one wave falls on the top of the another one. Okay, so that they cancel each other and we get the resultant is 0. That is the criteria for the destructive interference. Okay. Okay, so this is the constructive and destructive. Okay, now let's see the picture. See here. See, this is the interference. Okay, so crest and trough. See this one, that is constructive. Okay, so the blue one is the wave 1 and 2, and resultant we are getting, that is the yellow one. Okay, so see here the destructive, it is, though it is showing the little one, but basically it is the zero, that is the dark, completely dark. You see here, it is the original picture of the interference. See, the central strip is bright, then alternatively bright, dark, bright, dark. In this way, we get the pattern. Okay, right. Now, condition is that how you can get a good interference pattern. Okay, how we can get a good interference pattern, or what is the condition for getting a good interference pattern? Who can tell? 1 point.
সেম ফেস থাকতে হবে
Okay, one is that same phase. Okay, light blues are in the same phase. Then next, another. One is the same phase. Then number 2.
সেম ওয়েভলেন্থ
Okay, same wavelength, and it is related with the frequency. Frequency is same or wavelength is same. Okay, anyone you can write. Okay, next, third one.
অ্যামপ্লিটিউড সেম হইতে হবে
Okay, good amplitude. Number 4.
পাথ ডিফারেন্স কনস্ট্যান্ট হতে হবে
Okay, then number 5. What is the number?
সোর্স আর স্ক্রিনের মাঝখানে দূরত্ব বেশি হতে হবে
Achha. Source and screen, the distance between source and screen is large. Okay, so it is denoted at that is there is a way to remember this one. That is the source and screen is denoted as the capital D. Okay, it is denoted as the capital D. So capital D, it needs large. So distance between source and screen is unit, it is large, and distance between the coherent sources is less, and it is denoted as the small d. So small d you need less, and the large one, that is capital D, you need the large. Is that clear? That is for getting a good interference pattern, 6 things you need. That is same phase, constant path difference, that is same wavelength, same amplitude, and distance between source and screen is large. Distance between 2 coherent sources is less. That is the 6th one for getting a good interference pattern. Okay, next I'll discuss about the Young's experiment. Basically, with the help of the Young's experiment, okay, you can get a good interference pattern. Okay, now tell me one thing: is it possible that is 2 different sources you are using? So is it possible to make a coherent source that is same type of amplitude, same frequency, same path difference, create from there? Is it possible?
No, ma'am.
ম্যাম
No, ma'am.
So what is the shortcut? Shortcut is that is in that case when we have to use the source, okay, one source. Then from the one source we have to create 2 coherent source artificially. Okay, like see on the screen, that is S is the main source. Okay, here S is the main source. So from S we are creating 2 coherent source, A and B. These are the 2 coherent source. So in that case, see, as we are creating it from the same source, okay, source, wavelength, amplitude, okay, and they are in phase with each other. So these criteria they will fulfill. Okay, so we get wave from A and B, so they superimpose on each other. Okay, now look at point number G. See on the screen, the point is G. It is on the just at the middle. G is just at the middle. So now tell me, from the point G, A is near or B is near? From point G, source A is near to G or source B is near to G? Which one?
Ma'am, same difference.
Good. It is basically the same path. Same path difference. Okay, so the point G, it is in the just at the middle. So the distance from A to G is same as the distance from B to G. Okay, path difference is same. So that's why G is the central bright point. Is that clear? Then alternatively, on the both side, we'll get the dark, bright. In this way, we'll get interference pattern. Okay, and we can prove it by the with the help of the Young's experiment. Okay, now we already will see that this one is the, what is it? Do you know the name? Do you know what is it? The bright, dark, okay, we're telling this is the bright point, this is the dark point, okay. What is the name of this one?
Ma'am,
Is
fringe.
double slitted.
Hello?
Fringe.
Good, it is known as the fringe. Okay, it is known as fringe. Okay, so next our question is that we have to calculate the width of the fringe. Okay, width of this fringe. Is that clear? Okay, this is known as the fringe. So this is dark fringe and this one is the bright fringe. So next question will derive the fringe width. That is, it is denoted as beta. It is not B, it is beta. Okay, so fringe is denoted as beta. We have to calculate the beta for bright and another for the dark. Then we have to see which one is better. Bright one is better or dark one is better. Okay, that is one broad question. Next is the theory of interference fringe. So next is the theory of interference fringe. Okay, so theory of interference fringe, that is basically we have to calculate the fringe width. Okay, so for this one, we know from the Young's experiment how many things we need. How many things we need in Young's experiment? First, what is important? That is, we need a, yes, we need a light source. Okay, from the main light source, we have to create two coherent sources, isn't it? So we need two coherent source. Okay, so and then this one is A and this is B. Coherent source A, coherent source B, and the distance between these coherent source is a small d. Okay, this one is a small d. Okay, so wave is coming from S. Okay, so distance from A and B is small d. Okay. Next, we need what we need. Next, where we get the interference pattern? Where?
A screen.
Good. Yes, we need a screen. Next, we need a screen. This is the screen. Okay. Now, the distance from the source to screen, always remember that when you will calculate the distance of the source to screen, always take the distance from the coherent sources. Okay. So this one is denoted as capital D. So now tell me one thing. If you want to get a good interference pattern, which one is needed? If this capital D is a small or large?
Large.
Yes. Yes. Always remember D is large, so we need D large. Okay. So this is the capital D. Next, now we have to take central bright point. Okay, this is on the screen. This is C, and this one is central bright point. Okay, so central bright point. So it is obviously bright. Next, we take any point on the screen P. Okay. We take a point P on the screen. From the center bright point, the distance is x. Okay, from the central bright point, the distance is x. We take any point on the screen P. From the central bright point, the distance is x. Okay. Now, next, what we have to do? We have to calculate the path difference from A to P. Okay, that is the path difference from A to P and B to P. Is that clear? Path difference. We are getting light on P from the source A and again from source B. Now we have to find out the difference between the path difference. Okay. So this one is A. So light is going. So this portion is P. Okay. and from here that is B. Okay, so this one is Q and this portion is R. Now tell me what is the distance of PQ? PQ equal to what? Who can tell? PQ equal to what? From the figure, find out what is PQ. What is the value of PQ?
X minus
Yes, X minus
D by 2.
Good, very good. X minus D by 2. Yes. Why? See, this one is the D. Okay, A to B. So that is QR is equal to, basically QR is equal to D. So PQ equal to, that is this portion is, this is D by 2 and this portion is D by 2. So we can write that is PQ equal to X minus D by 2. Is that clear? Okay. Now tell me what is PR? PR equal to what?
X plus D by 2.
Good. X plus D by 2. Yes. Okay. Now come to next point. Okay. Now we have to calculate the part difference. Okay. No problem. So at first BP square minus just look at picture. That is our triangle A, P, Q. In this triangle, which one is the hypotenuse? A, P, Q. Hypotenuse, which one?
AP.
Okay. AP square. What we can write? AP square equal to?
PQ square plus AQ square.
Okay. Good. PQ square plus AQ square. Okay. Now, what is the value of PQ? PQ is
X minus D by
D by 2.
X minus D by 2. Okay. Now, what is the value of AQ?
Capital D.
D.
Yes, capital D square. Okay. Now come to triangle B, P, R. Which one is the hypotenuse here? Your hypotenuse is the, which one?
BP.
Yes, that is BP square equal to BP square. What we can write? BP square equal to,
square plus PR square.
okay, BR square. Oh, BR square plus PR square. Okay. So PR square plus BR square. So PR, we already can find out this one is equal to X plus D by 2. Okay. So in case of here, we can write X plus D by 2 per square. Then BR, what is the value of BR there?
Capital D.
B square. Right. Next, we will find out BP square minus AP square. Okay. So where is BP? This one, X square plus XD plus D square by 4. Okay. Then plus D square. Okay. Then minus this minus from the form. Okay. So here next is the X square. Then from here, so XD minus D square by 4. This is minus D square by 4. And here is minus D square. So this X square minus X square cancel. This one cancel. This cancel. So finally we get from here 2XD. So we get BP square minus AP square 2XD. Now tell me, what is the formula of A square minus B square? What is the formula?
A minus G.
Yes, that is A square minus B square. The formula is that, okay, we can write from here BP minus AP, then BP plus AP, okay, equal to 2XD, right? We get it. Now, approximation, we have to take it for the conclusion, we have to take an approximation. What is the approximation? We take that is BP is approximately equal to, it is not equal, it is approximately equal to AP, and this is approximately equal to what? Tell which one?
D.
Which? Here is 2D, small d, capital D. Which?
Capital D.
Yes, that is approximately equal to capital D. Okay, so from here, from this equation, we can write BP minus AP is equal to 2XD, then divided by 2D. Is that clear? 2D. So BP plus AP, it is approximately D. So D plus D, that is 2D. So 2 and 2 cancel. So from here, we get XD by D. Now tell me, what is BP minus AP? What is it? What is it? Yes, path difference. Good. That is the path difference. From there, that we are taking one point, that is here is P. We are getting light from B, okay, to P. Another one from A to P. So now we are calculating the path difference between these two. BP minus AP. Okay. So we get the path difference. Okay. So path difference here. So path difference, that is BP minus AP is equal to X D by D. Okay. Now next, up to this point you have to calculate. From here you may get 3 type question. Either you have to prove that is the for bright and dark both, or you may get question for the only for bright, okay, or you may get question only for dark, okay. So but whatever question you get in the exam, up to this portion you have to calculate, okay. That's right. So next is it. So up to path difference, we have to calculate for both or dark. For if you get only for the bright, then only for bright or only for dark. So you have to read the question properly. Okay, which are the answer. Okay. So path difference. This one we get next. We have to find out bright. Okay. Next we have to find out for the bright fringes. For the bright fringe. Okay, who can tell what is the criteria for the bright fringe?
Constructive interference.
Huh? Yes? Yes, we know constructive. That is we are getting the bright fringe. Basically, this one is a complete wavelength, isn't it? It is denoted as lambda. Okay? This is the lambda. It is complete wavelength. So
Lambda by 2.
No. Another one. This complete wavelength is multiplied by what? N. Yes, N. N is the integer number. N is equal to 0, 1, 2, 3, like this. Okay. But criteria is that complete your wavelength, you need a complete wavelength multiplied by an integer number. Okay? If you take one wave, no problem. That is take complete one. You can take 2 wave, okay, no problem. 3 wave, okay, 1, 2, 3, like this, okay. That is here. If it is central, then N is 0, okay. Then it may be lambda, it may be 1, 2 lambda, 3 lambda, like this, okay. That is, you have to take the complete wavelength. So if you want to get a bright fringe, in that case, our path difference, that is, we calculate x d by d, that is equal to what now?
N lambda.
Yes, that is a lambda. N is the integer. Okay, next from here we can arrange x equal to N lambda d by d. Okay. Now next, when n equal to 1, n equal to 1, then x1 equal to lambda d by d. Okay. Then when n equal to 2, in that case we get x2 equal to 2 lambda d by 2. We are calculating the bright one. Okay, we are calculating bright one. Now see here, it is on the screen. Interference pattern will get like this. Okay, according to Young's experiment. With central point, if you take it, this is central bright, then it is dark point. This one is dark point. Then this is again dark, and this is dark. Okay, and this one is dark. This is dark. It is the central bright point, that is the C point C. Okay. Now tell me, what is x1? Now tell me, what is x1?
First bright fringe from the central point.
Yeah.
First bright fringe from the central point.
Yes, that is, this one is the N1. Okay, this is N1. This one is N1. Okay. So, and which one? X2 is the X2.
Second fringe.
This is the N2. Okay. So X1 and X2 is basically the linear distance. Right? It is the basically the linear distance here. Okay. Like from the center. Okay. Linear distance. Okay. Now next one, we have to calculate x2 minus x1. Okay. So x2 minus x1, that is equal to what we get? x2 minus x1. From here, if you subtract these two.
Lambda d by d.
Yes, lambda d by d. That means this point, it is, you have to take it from the middle. You have to take it from middle. This portion is equal to lambda d by small d, lambda d by s1. This one is lambda. Okay, that is we get. Okay, next we have to calculate for the dark fringe. Okay, so next we calculate it for the dark fringe. Okay, so in case of dark fringe, now tell me what is the criteria for the dark fringe? What is the criteria for the dark one?
Odd multiplication of lambda by 2.
Very good. Yes, it is. Basically, first time, remember, that is half. In case of dark, it is lambda by 2. And this lambda by 2 is always multiplied by the odd integer number. Odd integer number means 2n plus 1. This number is always odd. Okay, 2n plus 1, and it is multiplied by the lambda, half of the wavelength. Okay, so we get this one. So we can write the condition for the dark one, that is path difference, we know x d by d. Okay, so here condition is 2n plus 1 lambda by 2. Okay, in the neutral swing we use it. Our next thin flame, we'll discuss about thin flame, then neutral swing. That time এখানে কিন্তু প্লাসের জায়গায় মাইনাস হবে, প্লাসের জায়গায় যদি মাইনাস হয় এটাও কিন্তু that is also integer number, odd integer number. Okay, আচ্ছা. So from here we can write x equal to 2n plus 1, then lambda capital D divided by, where is 2d. So same way, when n equal to 1, so when n equal to 1, that time x1 equal to what? N equal to 1, x1 equal to what we get from here?
ম্যাম একটা কোশ্চেন ছিল
হ্যাঁ বলো।
ম্যাম যদি আচ্ছা ইন্টারফারেন্সে কি সেন্ট্রাল ডার্ট বলে কিছু আছে?
ইন্টারফারেন্সে সেন্ট্রাল ডার্ক,
হ্যাঁ
আচ্ছা এখানে হচ্ছে গিয়ে তোমাদের নো, বাট নিউট্রাল স্ট্রিং এর ক্ষেত্রে যেটা হয়, আমরা সেন্ট্রাল পয়েন্টটা, এটা আমরা পরে যখন আমরা নিউট্রাল স্ট্রিং করবো, সেন্ট্রাল পয়েন্টটা ডার্ক থাকে, বাট সেন্ট্রাল পয়েন্টটা কিন্তু ওইটা ডার্ক হচ্ছে বিকজ নট ফর দ্য ইন্টারফারেন্সের জন্য না, ওটা হচ্ছে তার একটা কন্টাক্ট পয়েন্ট। বাট যদি তোমার পাথ এখান থেকে যদি পজিশনটা এ থেকে, এই যে তুমি এটা নর্মাল সেন্সে রাখো, যে ডিসটেন্স সমান হয়, তার মানে ঠিক আছে, অলওয়েজ সেন্ট্রাল পয়েন্ট ইজ what we get from here. How much we get from here?
Ma'am, 3 lambda capital D by twice D.
3 lambda d by 2 d. Okay, when n equal to 2, that time x2 equal to what?
2 lambda d by d.
5
Ma'am,
lambda.
n equals to 0 এর জন্য একটা কেস হবে না শুরুতে?
বলো।
n equals to 0 এর জন্য তো একটা কেস হবে, আমরা ফার্স্ট ডার্ক পয়েন্টটা পাবো।
n equal to 0 এর জন্য ফার্স্ট হবে, হ্যাঁ
0 হয়ে যাবে না?
ওটা তো 0 হয়ে যাবে, সেন্ট্রাল ব্রাইটিং 0 হয়ে যাবে, এইজন্য আমরা নিচ্ছি হচ্ছে
মানে 2n plus 1, এখানে যদি n equal to 0,
আচ্ছা এখানে হচ্ছে কি, তুমি যদি এখানে n এর এখানে 0 বসাও তাহলে তো কি হবে বলো, 0 বসালে
lambda d by 2d হবে,
lambda d by 2d। বেসিক্যালি এখানে হচ্ছে আমাদের নিতে হবে 1 থেকে, কারণ আমরা জানি সেন্টার রাইট পয়েন্টটা হচ্ছে কখনোই কি ডার্ক হয় না, তাই না? আচ্ছা তুমি যদি এখানে ইয়া হয়, তোমার যদি এখানে n equal to যদি 0 হয়, আচ্ছা ওকে, তাহলে x equal to 0, তাহলে এই ভ্যালুটা কত হবে তোমার বলো তো?
so ma'am lambda d by twice d হবে।
হ্যাঁ lambda d by twice d। আচ্ছা দেন নেক্সট এই ক্ষেত্রে, আচ্ছা আমরা যদি এখানে 0 দিয়ে করি, আমরা এখানে 0 ধরলাম, x এর ওকে, then x0 what is it? X lambda when n equal to 1, then x1 equal to how much?
lambda d 3 lambda d by 2d,
3 lambda d by 2 d, তাই না? ওকে, সো এই ক্ষেত্রে কি হচ্ছে, এই ক্ষেত্রে আমার ওই x0 বাই করলে তখন আমার সেম ভাবে কি হবে, ভ্যালুটা সাবট্রাক্ট করলে কত হবে, lambda d by d, isn't it? একই হবে সেম। এখানে যদি আমি if we give it 1, ওকে, দেন এখানে 1 হয়, এখানে 2 দিলাম, দ্যাট ইজ এখানে আমার তখন হয়ে যাবে 3, this one is 5, so x2 minus x1 that is equal to 5 lambda d by 2d minus 3 lambda d by 2d. So if you subtract this one, then 0 থেকে subtract করো, same value আসবে, so x2 minus x1 হচ্ছে lambda d by d, is that clear? Lambda d by d. So how much we get from the bright one, that is bright one, if it is our for the dark, for the bright, okay, now we are calculating the dark one, isn't it?
Yes, ma'am.
Are you listening?
Yes,
So now next হচ্ছে, এটা তো হচ্ছে তোমার একটা হবে ব্রাইটের জন্য, another one is for the ডার্কের জন্য, এটা হবে lambda d by d, ওকে। ফার্স্ট স্টেপটা কিন্তু আমার see, first for the bright, center is bright. C, this point is C, okay. So alternatively, we get this point is dark, this point is dark, and again this is dark, this is dark. So first when you calculate, that is the for the bright one, this one is n equal to 1, this one is n equal to 2. It is for the bright. ব্রাইটের ক্ষেত্রে আমরা লিনিয়ার ডিসটেন্স পেয়েছি কি ফর ব্রাইট, ওকে। দেন এই পোরশন দ্যাট ইজ ইকুয়াল টু ল্যামডা ডি বাই ডি। এখন আমি ডার্কের জন্য দিস ইজ n1 and this is n2, সো এখন আমরা কি পাচ্ছি, এই যে লিনিয়ার ডিসটেন্স এটা হচ্ছে ল্যামডা ডি বাই ডি। একটা জিনিস দেখো, যখন আমরা ব্রাইটের ক্ষেত্রে ক্যালকুলেট করেছি আমরা কিন্তু ফ্রিঞ্জ উইথ কাটটা পেয়েছি, বলো তো। When we calculate, okay, for the bright fringe, which one we get? Fringe with আমরা কাটটা পেয়েছি। It is so. এখানে হচ্ছে when we calculate the bright fringe, we get the fringe width for the dark. Is it clear? Then in case of dark, okay, when we calculate it for dark, then we get the fringe width for the bright. This portion. Basically, from here we can make a conclusion that is the distance between two consecutive bright and dark fringes having the same width. Is that clear?
Yes.
Is that clear?
Yes, ma'am.
Distance between any two consecutive bright and dark, okay, is the having the same width, okay. মানে আমরা যখন ব্রাইট ক্যালকুলেট করেছি তখন কিন্তু আমরা দুইটা ব্রাইটের লিনিয়ার ডিসটেন্সটা বের করেছি x2 - x1 ফর ব্রাইট, কিন্তু এটা বেসিক্যালি আমরা বের করেছি কি পেয়েছি ডার্কের উইথ। আর যখন আমরা ডার্কের ক্ষেত্রে বের করলাম লিনিয়ার যে n2 - n1 n2, তখন আমরা কিন্তু কি পেলাম ব্রাইটের জন্য। তার মানে বলা হচ্ছে the distance between any two consecutive bright or dark having the same width or same distance. বুঝতে পেরেছো?
Yes, ma'am. Yes, ma'am.
ওকে, এখন বলো তোমাদের আর কি কোশ্চেন আছে?
ম্যাম ওই 2n+1 টাই আসলে একটু মানে
কোনটা বলো?
একদম প্রথমে যে আমরা পাথ ডিফারেন্সটা ধরলাম 2n+1 ল্যামডা বাই 2, এখন n = 0 বলতে একদম সেন্টার পয়েন্টে কাউন্ট করতে, মানে সেন্টারের যে আমি যদি n এর মান 0 বসাই তাহলে আমি একটা ভ্যালিড মান পাচ্ছি যেটা পজিটিভ মান, যেটা ল্যামডা বাই 2। ভ্যালিড মান পাওয়া মানে কি, আমার কি সেন্টার ডার্ক আছে?
এখন তুমি আমাকে বলো, যখন আমার n যদি আমি ব্রাইটের ক্ষেত্রে কি 0 ধরতে পারবো? n এর ব্রাইট হচ্ছে বেসিক্যালি যখন আমার কি হবে, যে আমার ব্রাইটের ক্ষেত্রে, হ্যাঁ ব্রাইটের ক্ষেত্রে হচ্ছে ওটা পাথ ডিফারেন্স 0, তার মানে ওটা অলওয়েজ হচ্ছে ব্রাইট ফর্ম করবে, ঠিক আছে। আর ডার্কের ক্ষেত্রে কি হবে, আমরা n = 0 দিয়ে করতে পারি। n = 0, তখন x0 হয়ে যাবে কি ল্যামডা d বাই 2d, হ্যাঁ x1 হয়ে যাবে x1 = 3 ল্যামডা বাই 2d, ঠিক আছে?
ইয়েস ম্যাম।
না তুমি তো
Recording stopped.
তুমি কি বুঝতে পেরেছো?